The James Webb Space Telescope was built to explore the origins of the universe, to peer deeper into space than any telescope before it, to observe the first galaxies, the first stars, the earliest moments after the Big Bang. But instead of confirming what scientists expected, Webb has begun uncovering things that challenge the foundations of modern cosmology itself. One of its most astonishing discoveries began with something impossible: a runaway black hole. Far beyond the Milky Way, Webb detected a supermassive black hole racing through intergalactic space at nearly 4 million miles per hour. Black holes are normally found anchored at the centers of galaxies, surrounded by stars, gas, and enormous gravitational influence. But this one was moving violently, as though it had been ejected from its home galaxy during a colossal cosmic event. Yet the greatest surprise was not the black hole itself. It was what followed behind it. Stretching across nearly 200,000 light-years, twice the diameter of the Milky Way, Webb observed a glowing trail of newborn stars forming directly in the black hole's wake. A black hole creating stars. At first, astronomers struggled to believe what they were seeing. Black holes are known as engines of destruction. Their gravity devours matter, bends spacetime, and traps even light itself. But Webb revealed something entirely different. As the runaway black hole tears through clouds of intergalactic gas, it appears to compress that material ahead of it. The gas cools rapidly, collapses under gravity, and ignites bursts of star formation. Incredible as it sounds, the black hole may be acting like a cosmic plow, triggering the birth of stars instead of simply consuming them. The discovery stunned researchers worldwide. Because if black holes can both destroy and create, then their role in shaping galaxies may be far more important than scientists ever imagined. And Webb was only getting started. The telescope then turned toward one of the most violent galactic collisions ever observed, a colossal merger known as ARP 220. Located roughly 250 million light-years from Earth, ARP 220 formed when two massive spiral galaxies slammed into one another hundreds of millions of years ago. The result is chaos on a cosmic scale. Webb's infrared instruments pierced through enormous clouds of dust to reveal a galaxy glowing brighter than 1 trillion suns. At the center of this collision lies an inferno of star birth. More than 200 massive star clusters are packed into a region only 5,000 light-years wide. The amount of gas compressed into this area rivals the total gas content of the entire Milky Way. And hidden within the chaos, Webb still detected the original galactic cores, two ancient hearts slowly spiraling together toward an eventual merger. Around them burn enormous rings of newly forming stars radiating intensely in infrared light. Tidal tails and streams of gas stretch far into surrounding space like scars left behind by gravity itself. These are not comm systems. They are cosmic battlegrounds. And Webb is revealing them in unprecedented detail. Every observation points toward the same unsettling truth: the universe is far more violent, dynamic, and unpredictable than scientists once believed. Galaxies collide. Black holes roam through space. Stars are born from destruction itself. And the deeper Webb looks into the cosmos, the stranger reality becomes. As revolutionary as the runaway black hole discovery was, another Webb observation may prove even more disruptive. Because the telescope has now detected galaxies that appear far too old, far too massive, and far too evolved to exist so soon after the Big Bang. According to current cosmological models, the early universe should have been relatively simple. After the Big Bang, matter required enormous amounts of time to gather under gravity, forming the first stars and eventually the first galaxies. Large mature galaxies were not expected to appear until billions of years later. But Webb is seeing something very different. Some of the galaxies observed by the telescope already existed only 300 to 500 million years after the Big Bang. Yet these galaxies are astonishingly developed. They contain enormous amounts of mass, complex structures, intense star formation, and in some cases, sizes rivaling or exceeding the modern Milky Way. In cosmic terms, they appeared almost instantly. It is as though the universe skipped part of its own evolution. Using Webb's near-infrared spectrograph, astronomers carefully measured the redshifts of these objects, confirming that their light truly comes from the dawn of cosmic history. These are not nearby galaxies masquerading as distant ones. They are ancient. And they should not exist in their current form according to many traditional models. The implications are enormous. If galaxies formed this quickly, then something fundamental about the early universe may be missing from our understanding. Perhaps gravity behaved differently shortly after the Big Bang. Perhaps dark matter accelerated structure formation far more efficiently than predicted. Or perhaps entirely new physics waits hidden beyond current theories. Even more astonishing, Webb has identified massive protoclusters of galaxies forming only hundreds of millions of years after cosmic birth. These young systems appear destined to evolve into gigantic structures similar to the Coma cluster, one of the largest galactic formations in the observable universe. Astronomers now describe the early universe not as calm and gradual, but as explosive and chaotic. Galaxies may have merged rapidly through enormous streams of matter flowing across the cosmos like rivers of gravity. Black holes may have grown at impossible speeds. Stars may have ignited in violent waves across space far earlier than anyone imagined. And with every new observation, long-standing assumptions are being challenged. The Big Bang theory itself remains the strongest explanation for the origin of the universe. But Webb's discoveries suggest that our understanding of what happened afterward may be incomplete. Some physicists now speculate about hidden forces, unknown mechanisms of cosmic evolution, or even entirely new models of spacetime. Others urge caution, reminding the scientific community that extraordinary discoveries require extraordinary evidence. But one thing is undeniable. The James Webb Space Telescope has opened a new era of astronomy. It is not simply showing us distant objects. It is forcing humanity to rethink its cosmic history. And perhaps that is Webb's greatest achievement. Not confirming what we already believed, but revealing how much we still do not understand. Somewhere in the darkness beyond the reach of previous telescopes, ancient galaxies continue shining across billions of years of space and time. Their light carries secrets from the beginning of the universe itself. And for the first time in human history, we are finally beginning to see them clearly.